back again for some more notes. Haha, 8.2. What should I use as my main color today? This green is kind of calling out to me. It's like a seaweed green, maybe? I think it looks nice. Yeah, it speaks to me today. Last class, we learned things, we learned a lot of terms and a lot of words. We learned about, and I'll just kind of keep a list up here. We learned about, well, we learned what a term was. We learned what a degree was. And then we talked about naming them, how to find the terms, how to find the degrees, and all that stuff. Today we're taking that and we're adding and subtracting polynomials together. Wait, this is the wrong notes. Oh, that's right. Okay, yes, today we are adding polynomials. So, adding polynomials, that's just like adding like terms. So that's that first box that we'll write in. The question is what are like terms? So when I say like terms, what does that mean? Well, like terms are terms with the same degree. So, an example of this would be this. If I had 2x to the fourth plus 3x to the fourth, do you see here, when we look at the term, we look at the exponents. So here, this term, 2x to the fourth, has a degree of 4. This 3x to the fourth has a degree of 4. Well, we can add those together. When we do, you just add the numbers. 2 plus 3 gives me 5, and then I just keep my degree the same. Ooh, that got sloppy. So my answer, I can add the like terms to get 5x to the fourth. We always write our final answer in standard form. A reminder, standard form means we order them biggest to smallest degree. We'll get to see that in the examples again. Yeah, let's go ahead and head into some examples. My hair is doing whatever it wants today, but that's okay. We will just try not to be distracting though. Children are trying to learn here. Okay, in example 1, the question is, do we have any like terms? Well, here I see this 15x to the third. That has a degree of 3. I also see this 2x to the third. It has the same degree. So I can combine those together. I can add those terms, giving me 17x to the third plus 6x squared. I just left the 6x squared as is because there's nothing else to combine it to. So this is your final answer. In example 2, so what's my biggest term here? My biggest degree I see is this. Notice how there's a negative sign out in front of that 7x cubed. So when I write it, I'll write it with the negative 7x cubed. Well, what's my next biggest term? So we moved that around. My next biggest term I see is this 3x squared. Do I see any other x squareds, any degree 2's? No. So there's nothing to add there. Good deal. What's my next biggest term? Well, I see this 5. What's the term, or what's the degree, excuse me? On the 5 and the 12, our degree is 0. When we just have a plain number, so I'll write this in words. Plain numbers have a degree of 0. So here, I can combine that 5 and that 12. 5 plus 12 is 17. So here, this is my final answer. Double check, make sure this is in standard form. Biggest exponent to smallest. Yep, we're good to go. Okay, next, example 3. What we're doing here is we're taking one thing, we're taking this binomial, and we're adding it to this trinomial. When we do that, we put these parentheses, and it makes this problem look confusing. Let me tell you, the good news, don't worry about it. When we see parentheses, we ask ourselves this question. Do we do anything to the parentheses? When I look at this set of parentheses, there's no exponents up here. There's no numbers out in front. So we can actually just rewrite it without the parentheses. Well, what about this piece? Same thing, there's no exponents outside of the parentheses, there's no numbers in front of the parentheses, so we can just drop the parentheses. Or rewrite it without the parentheses, I should say. Now that we've done that, do we have like terms? I see this -7 and this -5 both have that degree of 4. Has that x to the 4th power. So I'll start by combining those. -7 minus 5, or -7 and a -5, give me -12 x to the 4th. My next biggest degree is going to be that 7x squared, and then that 8. Oh, we'll finish this up. I've been forgetting to classify these. So once we get done with example 4, we'll go back and classify these examples. Okay, so simplify, then classify the expression. Once again, we're asking, is there anything I need to do to simplify this parentheses? No. In today's lesson, you won't have to. So I can just rewrite 2x squared minus x. Is there anything I need to do with that other parentheses? There's no extra exponents outside. There's no numbers. There's no none of this junk. So we just copy it out. Now we can combine like terms. Here I see a 2x squared and an x squared. Remember, when we don't see a number, there's that invisible 1. So when I combine those, I'll get 3x squared. Then I see this -x and this plus 3x. Well, -1x and a plus 3x, that's going to end up being a positive 2x. And then I just have that -1. Double check to make sure your answers are in standard form. Here I have my biggest degree, my next biggest. Yep, I'm good to go. When I do these problems, I always work from the biggest degree to the smallest, so naturally my answers end up in standard form. If you do it differently, you'll just want to double check before you turn it in. Okay, last class we learned how to classify polynomials. So we learned that we can classify by degree and by term. Maybe I'll just make this list. A 0 degree we call constant. 1, 2, 3, 4, 5, 6 plus. 1 degree is linear, 2nd degree is quadratic, 3rd degree is cubic, 4th degree is quartic, 5th degree is quintic, 6th degree is nth degree. You will eventually need to have this memorized. Terms, I didn't give myself enough space. We call these nomials, just with different words out in front. 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, 4 or more we'll call it a polynomial. So here in example 1, what's the degree? Well, when I look at the degree name, I'm looking for the biggest degree, which is 3. But when I have a 3rd degree, I have a cubic. Actually, and let me do this. Let me copy this. Good. Okay, so when I have a 3rd degree, I have a cubic. Well, how many terms do I have here? I have 1 term, I have 2 terms. When I have 2 terms, I have a binomial. Spelling does matter. I need you to write out those full words each time. So here our classification is a cubic binomial. Example 2, let me move this and then paste. Haha. How cool. What's our biggest degree? Well, our biggest degree is 3. When our degree is 3, we call it cubic. How many terms do we have? Well, I have 1, 2, 3 terms. So that's going to be a trinomial. So once again, when we classify these, we give it a degree name and a term name. This here, same deal. Move that, paste this. Hopefully you have looked at this. Our biggest degree is 4, and we have 3 terms. So this is a quartic trinomial. Are all of these trinomials? Oh, the first one was a binomial. That's good. Lastly, in this problem, our biggest degree is 2. It's a quadratic. There's 3 terms. So we call this a quadratic trinomial. Okay. These other 4 are just more examples, but I think these 4 examples here should be enough. I will go ahead and make the subtraction video and post that. Let me tell you, it's basically the exact same thing as this, so never fear. Okay, break.